All right, 34. In the diagram below, AC is congruent to DF, and points A, C, D, and F are this funny word, collinear. Collinear, I'll line out. So collinear, it simply means share the line. Okay, all those points are on the same line. They share the line. And the way I remember that is cohabitat means you share a home. Okay? So co means share. So collinear means you share the line. Okay. Then at the bottom it says let triangle D prime, E prime, F prime, something we haven't done yet, be the image of triangle DEF. Be the image of this triangle there. Okay. After a translation along line L, there you go, there's line L, such that this point D is mapped onto point A. All right, that's something they tell you. Here's a question. Determine and state the location of F prime, right? Where is F going to land up here? That's the question. And I think it's fairly obvious. F is going to land right on C. But explaining this problem is the hard part, all right? It's getting the right language. So let's start off with this first given, that this side, A to C, that is literally the same length, congruent to side DF. That's what they're telling us here. D to F is the same length, and I'll make this a little bit thicker, okay, as the other one. So if we were to translate it, all right, and the way they're telling us to translate this, they're saying, look, move this thing so that D, it doesn't land on B, it doesn't land on C, translate it so that D, that top point right there, so that lands on A. And if you do that, you can see that, yes, D prime will land on A, and then F prime lands on C. Okay, so you now have your answer. You need to be able to explain it. So the first thing you're going to say is the transformation we did. We did a translation. All right, translation, and you can say translation preserves, maintains, preserves length. Okay, or distance, whichever one you want to say. Period. Okay, given that AC is congruent to DF. Boom, something they told us right there. If you tell me if point D is mapped onto point A, then point F, I'm going to say must map onto point C. And I think that's sufficient. We've stated that a translation is rigid. Right? That's the big idea, that these are rigid transformations. We're not going to change the length of something. And then we said, look, because you told us these pieces were congruent, all right, when we translate it, then we're not going to change the size. If you tell me D maps onto A, well then F has to follow suit. F can't go more than its original length, and it can't go less than its original length. The only place for it to land is on top of C. And that's what that's saying there. The second question is a little bit more involved, and let me clean this up so we can see. It says, let triangle D double prime, E double prime, F double prime be the image of triangle D prime, E prime, F prime. All right, so the triangle that we get from the D prime, E prime, F prime. From this is that translation, right? If we were to translate it just like we did originally, you get this. This is the first prime. Okay, first prime. They're saying, look, you're going to get this double prime after you do a reflection, a cross line out. So now we're going to reflect that blue triangle about this red line. Okay, they're going to tell you, look, E double prime, this point right here, this point is going to land on top of B. They're asking you, is triangle DEF congruent to triangle ABC? And yeah, it is. And when they ask you to prove triangles are congruent, the only tools you have are the congruence postulates, like side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. And if we think about this, this is right here, one side. So when we reflect, E is going to land on top of B. Okay, so E double prime will land there. So we can say this red length is congruent to that blue length, because when you do a reflection, that's a rigid transformation. Size is preserved. This side AC is going to be congruent to DF because it's not moving. It's also rigid transformation. And not only is size preserved, but the shape, right? The angles, they're all preserved. So this angle from the blue is going to be congruent from this angle in the red. It's just going to map right onto it. So we can say those triangles are congruent by side, angle, side. And this is all a consequence of reflection. So you can say, yes, triangle DEF is congruent to triangle ABC. I'm literally just rewriting what they're saying. And now I need to explain. Since reflections preserve length, or size and shape, I'll say. Size and shape. Triangle DEF is congruent to triangle ABC because of side angle side. So you know what? We could have saved that to the end. Okay, but it doesn't hurt to be a little repetitive. You can leave that in the front. And this satisfies our answer. We established why those triangles are congruent. We stated the rigid motion, reflection, that it preserves size and shape. That's getting that extra side, that extra angle, and we're giving them the reason, right? That's us explaining the answer. They said explain, so this is sufficient. It's just kind of us telling them what's going on. If they said proof, this would be a little bit more involved. So there's 35. 34.